the main reason why transformers don't really work for images is that images are made from red, blue, green colors, and then potentially a fourth one, an alpha, which is transparency. And so that doesn't map to tokens because like you've got billions of colors. So you can't map every single color and every transparency level into a token. That doesn't work. And so what happens is with diffusion models, you start with noise and you work backwards towards an image.
Welcome to Practical AI, everybody. My name's Jeff. I'm here with Peter Lynn. Practical AI is brought to you by Pocket AI. Pocket AI is a tool you can use to edit the weights of your model. With Pocket AI, you can prune over 60% of the weights in your model while increasing accuracy. Peter, all the rage this week is VO, and I know you've played with it a little bit. And so I first want to just get your impressions, but then I wanted to talk a little bit in depth about diffusion models versus transformers. So what are your thoughts after seeing for about a week now the new video models from Google?
It's definitely an improvement over VO2, but it still has issues. Like some of the clips that people have generated, like a wolf chasing a rabbit through the woods. Like the physics, I mean, it's high res, so it looks fancy, right? It looks impressive, but the physics of it is all wrong.
Do you think that's because it's been training on wrong images or wrong videos?
No, I think that these models don't understand physics.
Right, but how can they break physics if they've never seen physics that's wrong? Or you know what I mean? It's only can spit out what it's been trained on.
Exactly. Yeah. So basically, what they do is they've well, first up is you train an image generation using diffusion, right? So you say, give me a barber in a barber shop. So it starts with noise and it generates more and more until it gets to a barber in a barber shop. And the next step is you can then say, okay, now I want you to generate a barber cutting someone's hair. So it takes one image and it tries to modify it slightly, and then it takes that image and modifies it slightly. So then it does this process to generate several frames to make a video. So, but in that, it has no understanding of what a human is, how many joints a finger has, how many joints are involved in an arm, right? So it has no understanding of physics and kinematics and just the anatomy of an actual living creature. So it's just saying, okay, here's a likely thing I can modify in the image to give you the next frame.
Sometimes I wonder if these things were trained on like old Hollywood CGI because some of the like relationships to gravity and physics and stuff like that, they seem just slightly off, right? It's almost like um, an early Marvel, or maybe even going back farther into like Cameron's, Avatar or something like that, where it's just a little bit off. It's great, it's amazing, but it's just a little bit off in terms of its relationship to reality.
Yeah, so I don't think that it's trained on, well, so it's trained on everything on the internet. It's trained on all the YouTube videos, which obviously because Google owns YouTube, they can use everyone's videos, and we know they've got terabytes and petabytes of videos. So they've trained on it, but again, it goes back to it doesn't understand physics, it doesn't understand anatomy, and so it's just guessing what the next frame is. And until it understands physics, it's not going to be able to accurately choreograph a fight, animate something with weight. So like a lot of examples, the wolf running through the woods, it feels very weightless, right?
Yeah.
Because things aren't deforming the way it's supposed to be when the wolf steps on like a branch or a leaf or grass. It's not bending in the way that you expect. It's not deforming the things around it in the way that you expect.
Yeah. So let's say you're an engineer at Google and you have this video of a wolf running through the woods and it's just slightly off and you want to make it better. What do you do? Like,
Today, you just get more video and you just generate more training.
okay, so this is just they're just going to keep pounding and pounding and pounding until they brute force this thing through.
Yes, because a human being can't sit and watch 4 petabytes of video to figure out what video you should train on,
Yeah. All
right?
right.
I mean, like it would take you 1,000 years
This
to
is
like,
sort of the segue into the two different types of architectures, and we really haven't gotten into this. But um, in short, there are two different types of ways to do AI. One is with transformers, and then the other one is with diffusion. Explain those, for the person that doesn't, do this for a living,
right.
um, and why one is used and one is not used.
So there's actually more than two, but the two most popular are transformers, which is from the Google paper, Attention's All You Need, and then there's diffusion. And diffusion's popular with Midjourney, Stability AI, VO, and all the image generation models, right? So the reason why Transformers is called Transformers is just that's just the name they gave it. So the original problem they were trying to solve was we need to translate text from one language to another, and it was slow. So they're using what's called LSTM, long short term memory, but it's sequential. You have to feed something in, and then it feeds the whole thing in again. It generates more. It feeds more of it. So it's a sequential process, and it's really really slow. Like it used to be that LSTM would take 4 to 10 times longer to train.
And
And
it's
so
both the training and the runtime, right? The
yeah.
inference side, right? So explain the difference between that
So
with the and
training is the stuff you do to teach it the patterns it needs to know. And inference is when a human interacts with it. So when the Google team said, "All right, we need to improve translation," they said, "Okay, how do we make this so it can run in parallel?" So then, well, okay, we've got text. We can chunk it up. So if we got like, let's say we take um, a novel, we can take any novel, like a Stephen King novel, for example. We can take Cujo, we can break it up into chapters, and then we can assign one GPU to do each chapter. And all we do is we go, here's a sentence. Let's lop off certain words, and then ask the system to predict what those words should be. So like maybe like you take the first sentence of the intro to Cujo, and you just literally cut half the sentence off. And you go, okay, complete this sentence for me. And so you can spread this now across thousands of GPUs, and it's much faster than using one GPU and doing things sequentially. So that's the big improvement was you could train a language model without having to manually have a human generate data. You just go, here's the data, we're going to chunk it up, we're going to randomly remove stuff, tell it to predict, and it'll learn what language is supposed to be like. It understands what the grammar is, and then so that's the kind of the training part where
there's a scoring mechanism there. Someone or something is saying, yes, you got the word right, or good try. This is
yeah,
80% accurate, or something like that, right? Is that a human?
during training, all it does is it just tries to get the exact sentence that you've broken up.
And it's either yes or no. You either got it
It's just
right or
yes
you
or no.
didn't.
Yeah, yeah.
Okay.
So then it just goes through and it gets refining the weights until like it predicts, right? Because if you have a sentence like "I went to the bathroom," blank 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 blank, right? So you know what the original sentence was, and you know what you want to get out of it. So you just train it until it gets that sentence correct.
Got it.
Um, then at runtime, we do additional things of like, hey, we ask it a question, it returns a response, and so that part is completely sequential, right? Let's say I ask it, where is like what's the capital of New York, or what's the state capital, and it says Rochester. You're like, no, Rochester's not the capital of the state of New York. Try again. And so when you do this, it just keeps feeding your response, including its own response, back into it, and it keeps doing this. So it's
Okay.
sequential.
This is on the runtime inference side.
Yeah. Yep.
Okay. And this is where it's like um, single threaded or whatever you call it, where it's just one gate that's going through.
Yep. Yep. And so
And
that's why like when you have a really long prompt, the context window is important because if you have a long conversation, or if you feed, let's say you feed it Cujo, and you say, "Give me a summary of chapter 4 of Cujo." It's got to read the whole entire thing up to the end of chapter 4. in order to summarize for you what happened in chapter 4. And so the context window now is important because we've stuffed the prompt with 4 chapters,
Hmm.
right? So this is the same thing with with programming. When you give it a large code base and say, explain to me what this code base does, it has to consume the whole entire code base in order to figure out what it's actually doing. And so that's the context window thing.
Now, when there's the just before we get into diffusion models, if you train the book or if you trained on that book, Cujo,
Yeah,
you may not have to stuff the context window. It may just be in the base model, right? You could
correct.
just yeah, okay.
Yep. So this is where the whole brag thing comes in. Like if you have your own business documents, which it never trained on, but it understands language enough to be able to process that actual content and then try to extract out a summary, right? So this is that whole retrieval augmented generation where you've stuffed the prompt with additional information and you tell it hey, read this for me and tell me what it means.
Hmm. All right, so now that's one side, and it's tokens
Yep.
and tokenizing into transformers, and then on the other side you got this diffusion. So just real quick at a high level, what are diffusion models and why are they used and when are they used?
So the main reason why transformers don't really work for images is that images are made from red, blue, green colors, and then potentially a fourth one, an alpha, which is transparency. And so that doesn't map to tokens because you've got billions of colors. So you can't map every single color and every transparency level into a token. That doesn't work. And so what happens is with diffusion models, you start with noise and you work backwards towards an image. So it starts with basically it looks like in the old days when we had TV that were CRTs, and when the TV went off, and you had that
Yeah.
statically white noise thing. That's what it starts from, and it tries to generate images from that. So if you say "Give me a bicycle," it starts with that, and it keeps modifying it until it gets to bicycle.
And it's you said that in transformers you train in parallel, but the inference is single threaded.
Yeah.
But in diffusion models, you train in parallel, but its runtime is in parallel. Explain that a little bit.
Well, so because the fundamentally different kinds of data, if you say give me a 4K image of a dolphin jumping over a rock in the Pacific Ocean, what it does is it chunks up that 4K image into smaller pieces and it generates it
Okay.
more efficient.
Is it literally like sections of the screen, or is it like overlaid?
No, so when you're training it, it tries to do this in parallel, and most of it comes out as garbage.
Yeah.
Right? It doesn't make any sense. But once it's trained, when you tell it, generate me a dolphin jumping over something, right? It understands at that point what a dolphin is, or it doesn't really understand. It knows how to generate a dolphin, it knows how to generate an ocean, and it does these two things together, and so it literally just breaks it up into chunks and says generate.
Okay. Cool. Well, people are having a lot of fun with VO, and seems like Google's a little bit ahead on this relative to some of their peers, but everyone's catching up at all the times. And
Yeah, and I think Google has the benefit of they have their own TPUs.
oh, well, and they've got all of YouTube.
Well, they have all the YouTube, they have their own their own hardware, and they have NVIDIA hardware. So they're at a huge advantage because OpenAI only has NVIDIA GPUs.
Hmm. Well, it's good to see the acceleration here, and really glad that we got into the Transformers versus Diffusion because that was a topic that surprisingly over 2 years we haven't actually touched yet. I don't think so. Good, Peter.
Yeah.
Thanks for the update and thanks for sharing your wisdom. We'll be back next time with another topic. Be sure to follow us on Spotify. We are there if you only like listening to stuff. And remember to always watch us in double speed because Peter and I talk slowly. Thanks and take care, everybody.